so tired. I'm going.
Hey, you gotta focus then. You got a game tonight.
Yeah, it's gonna be so hot. I might die tonight.
Drink water.
I've filled this up like 3 times. And I took my allergy medicine this morning. I still don't feel bad.
I'm sorry.
What's
Would
that
you like
big
a
yellow
cough
line
drop?
on the side of the TV?
That's my recording. We're getting a recording of you complaining about how you
So
feel.
if anyone ever.
So, if anybody wants to go back and
A little
relive this
trauma.
moment, it's here. Alright, so the next thing we need to talk about, we did standard deviation, range, variance yesterday. We talked about the difference between sample and a population on those formulas. We have the empirical rule. This is a rule for bell-shaped data. Okay, so we know if it's like symmetric bell-shaped data, it follows this pattern, right? And most of the data is going to fall in the peaks of the curve, right? So this is actually an actual distribution. If it is bell-shaped data, and only works if it's bell-shaped, 68% of your data will lie in one standard deviation of the mean. 95% of the points will be within 2 standard deviations, and 99.7 will be within 3 standard deviations. Now, this is a lot if you're trying to remember it, but what are you allowed to have? Formula sheet. Does anyone have their formula sheet handy? Okay, look, right under variance, there is an empirical rule, and it has the 3 bullet points, and it tells you these percentages. Okay, so it's all given here. We just have to be able to apply it. So I want to kind of explain it in terms of an example. Let's say I gave you a set of data, and in my data, the mean is 60, and we have a standard deviation of 4. Okay, so mean is the middle, right? If it's bell-shaped, so this is 60. Within one standard deviation, so a standard deviation is 4, so 4 below would be, and 4 above. So I'm saying if you list out your original points, 68% of those points would be some number between 58 and 64. All right, 2 standard deviations, so you just subtract your standard deviation again. So that would be 52 and 68. Sorry, I was doing the 2s. So, empirical rule says 95% of your points would be a number between 52 and 68. 3 standard deviations, so that would go down to 48, and so that means 99.7% of your points would be something between 48 and 72. So would it be likely to have a number less than 48 or bigger than 72? No. Are there going to be some? Sure, we still have 0.3%, so there'll be something there. But it's saying the bulk of the points fall between those. All right, do you guys understand what that's saying now? Let's look at an example. So, following are giving us cholesterol levels of 54 patients of a family doctor. Okay, we even have a distribution here. Determine the percentage of patients that have a cholesterol level within 3 standard deviations of the mean according to the empirical rule. All right, so empirical rule says, does this data appear bell-shaped, first of all? Yes. Is it perfect? No. So are my real percentages going to match the empirical rule perfectly? No. How many should be within 3 standard deviations? 3 standard deviations. Should be 99.7%. That's what I would expect. Determine the actual percentage. Come in. Okay. All right. I want you guys, So if I want to know the percentage of patients that would have a cholesterol level between 34 and 69.1, according to the empirical. For the empirical rule, I need the mean and the standard deviation, right? Do I have that information? I have the ability to get it. What would be the easiest way to get it? Calculator. Yep. So enter all of this in your L1. Would be 11.8. All right. So think about this curve for a second. My mean, what did we say that was?
57.02.
So that's the center. If our standard deviation is 11.8, then if I take 57.4 and subtract it, that's 45.6. If I subtract it again, 33.8. I'm trying to find values between 34 and what? 69.1. Let's go the other direction. So if I do 57.4 plus 11.8. Plus 11.8. Alright, do you guys see how I'm getting these? I want everything between 34, 69.1. So it would be these three bars. Alright, now this thing is symmetric. We know that in the first standard deviation we have 68%, right? So that means each of these rectangles is representing 34. Alright, in the next chunk, how much do we have? 95. Okay, so if you wanted to think about that, 95 minus 68 is 27% between these two rectangles on the sides, right? So if I divide that by 2, each of these would be 13.5% of our data. You guys all with me there? And didn't I give that to you in this diagram? I haven't really talked about it a whole lot, but I gave you those percentages. That's where they come from. So if I want these three rectangles, all I have to do is add up my 13.5, my 34, and my 34. And what would that give me? So I would expect 81.5 to be between that. 81.5% of my points. All right, so let's find the actual percent. So to find the percent, we have to find the number of points and divide by 54 because there were 54 patients. So I need to know how many numbers were between 34 and 69.1. I think it would be easier to just find the ones that weren't. Can I do that? You guys count. Let's all count. We'll see if we... So I got 45 points in that range. If you divide those, you get 0.83 repeating. So we got, in our actual data, 83.3%. Is that pretty close to the 81.5 that our empirical rule predicted? Yeah. Is it going to match exactly? No, because our data wasn't perfectly bell-shaped, but it should be close. This only works for bell-shaped data. So if it's not bell-shaped, we need a different rule, and that is Chebyshev's inequality. So Chebyshev's is a little more conservative. It says 1 minus 1 over k times 100%. And I did include this one on your formula sheet. I just gave you the 1 minus 1 over k squared. So, for instance, if I want to know, k is the number of standard deviations. So if I said within 2 standard deviations, you would do 1 minus 1 over 2 squared. Okay, and that gives you 0.75, so that's 75% of the points. So notice, empirical rule says how many are within 2 standard deviations? 95. This is 75, because if it's not bell-shaped, it's a little more spread out. Okay, so the percentages are lower. So, using that, I want to determine the percent of patients that have cholesterol levels within 3 standard deviations of the mean. So we said it wasn't perfectly bell-shaped if we decided it wasn't close enough, and we did this instead. So that would be 1 minus 1 over, my k is 3. So you get 0.888 repeating. Or 88.9%. You want to see how that really compares on our data? We need to know if we wanted within 3 standard deviations. We'd have to go back to this. So we would have to do 33.8, subtract another standard deviation, so that would be 22. Here I have to add another one, 92.8. So we need to know how many are between 22 and 92.8. How many aren't? Yeah, all of them are in that window, aren't they? There's not any that don't fall in that window. So on our actual data, it was 100%, right? That data was a little more bell-shaped, so that's why our percentage is higher than Chevyshev's predict. All right, any questions there? Last thing I want to talk about is the only piece that I'm covering from section 3, and it's a weighted average. If you want to know how your GPA is calculated, it's a weighted average. A's count for 4 points, B's count for 3 points, C's count for 2 points. And so you get points for your grades, and you divide it by the number of classes you have. That's your GPA. That's called a weighted average. So to find these, I think this formula is a little bit confusing. It's basically you take the weight times the number of points, and then divide by our total. I think it's easier to look at an example on these. So Bob goes to that should be weight, nut store and creates his own bridge mix. He combines 1 pound of raisins, 2 pounds of chocolate covered peanuts, 1.5 pounds of cashews. Raisins are $1.25 per pound. Chocolate covered peanuts are $3.25 per pound. Cashews are $5.40 per pound. I want the cost per pound of his mix. If you're confused, units can help you a lot. Cost per pound. So that means the top of my fraction has to be the cost. The denominator has to be the pounds. All right, so to get our cost, we have 1 pound of raisins, and they cost $1.25 per pound. So you have to take your $1.25 times the 1 pound we bought. Chocolate covered peanuts, we have 2 pounds and they were $3.25. So we do 3.25 times our 2. Cashews are $5.40. We take our $5.40 times 1.5. People get confused on what to divide by on these sometimes. Do you divide by the dollars or the pounds? Look, we want pounds. So my total pounds would be the 1 plus 2 plus 1.5. get a total cost of $3.52 per pound. So that's called a weighted average.
You put per pound?
You can. I just asked for the cost, so if you just said the dollar amount, that would be fine. But if you said per pound, that's also correct. Any questions? So we have a chunk of time. I'm hoping you guys can get some homework done and not have so much to take home. So we are now done with these two sections. Remember, I gave you those problems yesterday. Hopefully you've done the first 4.